Hello, I'm audible, right?
Yes, sir. Yes,
Yeah,
sir.
yeah. So maybe we'll just start.
Okay, sir. You
Yeah,
can carry on. It will be
yeah.
uploading it to YouTube anytime they'll use it, sir.
Yes, yes.
You can start, sir.
So welcome you all to this live session on a numerical methods for engineers taught by Niket Kaisare. I am your teaching assistant for your course. So in specially teaching assistant is I'll just introduce you to myself in that regard. I am basically a PhD student at IIT Guwahati, and I was awarded a Prime Minister Research Fellowship in 2021. My research topic is about the lithium ion batteries. So how I would be beneficial to you for this course is, for these lithium ion batteries I am trying to understand how these batteries are taking fire. So you must be knowing outside EVs are getting rolled out, but battery catching fire is an imminent problem. So what we are trying to do is, with the help of simulations, trying to understand how these batteries are catching fires and can we predict those fires. Like can we have a fault detection mechanism or a fire detection mechanism, so that it will not be a big problem in. So yeah, so that was about my introduction about what I'm doing at IIT Guwahati. So in that battery simulation, how I'm going to help you with these numerical methods is, see, we cannot introduce the fire in the battery in the experimental setup. So what we are trying to do is, we are using some mathematical models which are ordinary differential or partial differential equations for the lithium ion batteries, and trying to simulate it. So for simulating so large number of differential equations, we are using a numerical method. So why I'm using numerical method? So I have used these techniques and quite a bit understanding of it. So I am also learning this with you all. So this my background knowledge might be helpful for you in this teaching, giving you some basic ideas. So what these sessions are all about is, so agenda of these sessions would be, we expect you all to go through the video lectures before coming to this session, because here we are not going to teach you each and every concept per se. What we are going to do is, we are going to give you some numerical problems, or going through, which would be aligned with the what theory has been taught. So that would be a good revision for you, which would be helpful for you to solving the assignments. So your assignments going to give you the grades at the end. There are some points for your assignments, and here we'll just go through the what is, how to solve those problems related to the field, related to the week that you have been studying for. So we this is the first session. So for the first session it's okay, but when you're coming for a next session, we expect you all to at least go through the lectures, so that it would be beneficial. uh, the next thing would be the books for this course. So there are this is the seminal book, Numerical Methods for Engineer by Stephen Chapra and Raymond Canal. Seminal book, standard book, everybody uses this one. In IITs also, professor use this one. Then questions from this. We will also do what is, we will take the unsolved numericals from these books in per se, and get to know how to solve this. This is also very good author, Indian author, and this is the one B.S. Grewal is also good author. If you don't, some people don't like foreign authors, so they can go through these two books also. So, but Capra and Chapran Canal would be sufficient in my opinion for this course. So recordings would be available to you. Am I audible, right?
Yes, sir. Yes, sir.
Yeah. So the recording would be available to you on the this YouTube channel. This is just a specific YouTube channel created for this course itself. So I would be uploading the sessions after the session gets completed on this YouTube channel, and then you can go through the video again at your own pace, at your own timing. But we encourage you all to come to the live session, so that if you have any doubts, you can talk to me one on one. If I don't know that, I will come back again in the next session and try to solve that query. But it's if platform is giving you free opportunity to have interaction online, so you better use it from the next session. So I'll just go through the what has been taught till now. So we started with the introduction and the motivation for this course. So can you tell me why to study these numerical methods? Like, what was the motivation? Like, why to study numerical? What is the difference here? Sir, can you just have any thoughts about it? Do you have any thoughts?
So final things is the experimental is time consuming and cost consuming, but numerical analysis is it saves money.
Yeah, that is the one way. But if you have a new even if you model something, can't you solve it directly? Like, if you have ordinary equation, you can directly solve using CA plus via complementary functions and particular integral, and then solve. You also have, for let's say you have
Accuracy of the result is
x square plus bx plus c is equal to 0. If you have, you can directly just put that quadratic equation formula, right? B is a plus minus b square minus 4ac divided by 2a.
But the main reason sir only told in the class is this is good for the higher order of calculation.
So what happens is when your
If
system
approaching real time is more accuracy.
yes, even when your system gets most, so sometimes the system, what happens is when you can get the direct this exact solution from these analytical methods, but sometimes these analytical methods have some problems when you're dealing with the higher order systems, or it is a time consuming. It's not what we say. It's time consuming, even computationally exhaustive. Even if you try solving it using a computer, using a symbolic maths, it is also going to take a lot of time. So that in that case, what we do is we go for these numerical methods, where we are going to have some algorithms which we going to repeat it one after again and again to get down to the solution. So the algorithm can be directly applied and get to the solution, and can be iteratively. So for that, we saw what is the error and approximations, what is error. So let's say in this case there would be a x value of some x, right? So there would be for this one there would be x1 and let's say x1 and x2. So there is x1 star and x2 star in this case, right? So this x1 star, x2 star are the correct values of this quadratic equation, or the roots of the quadratic equation. But because of the numerical method, there will be some errors. So the value we will get will be some different from the some error would be there. So that error we get in the two forms. There is a relative error and there is a true error. Epsilon is a relative error and a true error. So true error is just the mod between your x star and minus x, is your x star minus x divided by x star. So this we saw in the error approximations. We saw what is a Henon algorithm there. So you can just again go through the video lectures and get down to the what I'm talking here. Then we saw why this error comes about in the numerical analysis. So in numerical analysis there will be some truncation and a round off that we do. So in the case, let's say you have a Taylor series approximation. So Taylor series approximation goes as f of x is equal to f of a plus f dash of a into h, or you can say x minus a, the plus f double dash of a x minus a square divided by 2 factorial, and so on. So what we do is we do truncation. So we will reduce these higher order terms and just consider the low order terms. Because of this truncation there will be some errors. Then what happens is there is a rounding off. So if you have a 0.1288, and I told you it's a 3-point rounding off, so you might do is 0.129 and you will round it off somewhat. So this type of things will introduce the errors. So this that we have seen. Then we saw talk about the binary number and floating points, where we saw what is a mantissa, what is an exponent, how exponent determines the what will be the smallest value and the highest value of the method of this what we say of the representation would be. So that we all seen. Then we talked about 3 different methods: iterative, direct, and sequential method. So can you tell me why we have different iterative, direct, and sequential? Can't we use a one method direct to solve these problems? Like, why to go for a different methods here? Sir?
It is a different approaching, and you'll get the accuracy also varies, sir. They're using by iterative method, direct method, sequential method.
Yeah, its approach would be different, particularly in the different case. So what happens is, some of the problems, it is about the problem that at your hand. Let's say if you have some question that can be solved directly with the one direct approach, and it is you know that it is not going to be computationally exhaustive, you can directly use the direct method. But for a same problem, if you know, and that same problem can be solved iterative method also, I will tell you. But
Okay.
the problem, the thing is, it is not useful to do. I mean, it is wasting your energy to doing this or this method while you are good enough to go for direct method in that case. So yeah. So what I was saying is, it all depends on the what kind of a problem that is in your hand, and that will decide which kind of a method that you will solve or use.
Okay.
So this was about some quick revision about what happened in the last class, I mean last week itself. You can always go again in the lectures and get back to me if you have any doubts. So now what we'll do is, we'll go through some few sample questions which will be aligned with what your assignment is there, so that you can solve this assignment in a better way. If you have any doubts, that might get solved. So let's just get there. Yeah. So this is the first question we have. Let A is equal to this, B is equal to this, C is equal to this. Using d-digit rounding, compute A plus B plus C and A plus B, B plus C bracket C, and A plus B bracket plus C. So do you see, are they similar here?
Look like similar.
Analytically similar, right? So we'll just go through it. Let's see what happens. Okay. Let's see. So let's say A plus B plus C. So they are saying do 0.00456 plus 0.123 minus 0.128. So if you do this addition, you will get 0.982 minus 0.128. Okay, this value will get, and what the final value would be 0.984. This will be A plus B plus C.
Okay.
Sorry, this subtraction is it's a 0.127 minus 0.128, and that would get down to the 0.001. Yeah. Right. So this will be your value for A plus B plus C. So now we'll do is A plus B plus C. So it's a 0.00456 plus 0.123 minus 0.128. So now we are keeping this constant here, so 0.0. So but 0.0456 plus this value would come down to be how much? 0.005. So if you add this, it would be something 0.0044 something something. It will come like this.
Minus 0.005.
Minus, yeah, sorry. There is a minus, right? That is why this is this thing. So in that case, so what we are doing is it is 3-digit rounding off here. So in that case, it would come out to be a 0 here, right?
Yes.
So can you see, is there a difference?
Now is getting difference.
Yeah. So can you just think why it is so? Meanwhile, I'll just solve the second one. Let what it is giving you now. Let A is equal to, so A, these are some values, again 3-digit rounding, and again they have used the distributive law here. A into B is equal to C, and it is distributed here. Okay. So distributive law. Let's see. So this was associative. Now we are talking distributive. So for distributive, let's say for the first one, what they are saying, A is into B plus C. Let me just grab my calculator so that.
Okay.
Yeah. So 2 into B plus C is minus 0.6 plus 0.602. So what do you get? 2 into 0.002, right?
Okay.
Is equal to what? 0.004. Now A into B, sorry, A into B plus B into C, is it right? It's distributive they are talking, right? So 2 into minus 0.6 plus 2 into 0.602. This would be minus 1.2. This would be 1 point. How much? 1.204. So it would come out to be 0.004. So here you can see is the similar. So why is it happening? So associative is not doing good, but distributive is doing. Distributive is not, associative is not matching up, but distributive is matching.
Okay.
Can you just give any comments on this?
No idea, sir.
So if you see, if you just see the values of each and everything, and get down to some conclusion, then we will just move ahead with it.
Because negative numbers is existing because of that reason.
So negatives also exist in the both of the case, right? One negative and two positives are there.
The signs indications changes the laws, maybe.
Maybe one could say that because there is an integer in the second one and the rest of are fraction numbers, because of that two it is getting multiplied. That could be a one possible solution, like one possible hypothesis. But if you go for, let's say, we'll use the values of the first one and try to solve the distribution. So let's say what is the value distribution is A into B plus C, right? So values are like 0.00456 into 0.123 minus 0.128. So this would come out to be minus 0.000022. So by 3-digit counting it should be 0, right?
Okay.
And again, if you come down as a into B plus B into A, same thing. If you come at, like in that case, for the first one it would be 0.00056 plus 0.00058 something, and if you 3-digit rounding you do here 0.00101 and minus 0.0001, again you will get 0. So it's basically a case of that multiplication is there, right? That multiplication is actually removing the this thing error. That is the takeaway from here. Okay, so we'll just move ahead with the next question. Now you're following along, right? You're understanding what I'm trying to
Okay.
right? So let's get to this question. Now evaluate the polynomial y is equal to x cube minus 7x plus 8x is equal to 0.35 at x is equal to 1.37. Use 3-digit arithmetic with chopping. Now last case you were doing rounding. Now it is chopping. So we'll see how this is different. Evaluate the percent relative error. So he's asking you to find out epsilon, right? So repeat A, but y is now this expression. Are this expression and this expression similar?
But look like not similar.
Yeah, but if you just expand
Multiply
this, x it would be x cube is 7x into x 7x square plus 8x plus 0.35. So analytically these two are similar, right? But again we'll use this, we'll solve get the value of y and let's see what we can see out of it. So let's say y is equal to, for a first case for a case what they say, x cube 7x square plus 8x plus 0.35, right? So first we require x cube. So x cube as 1.37 cube would give you what value it would give you? 2.57. Okay. For x square 1.37 square, that is 1.87. So what you're saying is 1.37 square. So the value is coming out to be something 1.8769, right? So I am chopping off, 3-digit chopping off. The rest of the values I am not considering. So this is 3-digit chopping off, not rounding. So if the rounding would have been there, the 1.877 would be there. 1.878 would be there. So we are talking about 3-digit chopping off now. So let's go ahead, and x we know. So let's just calculate value of this thing, x 2.57 minus 7 into 1.87 plus 8 into 1.37 plus 0.35. What you will get? You will get 0.79. You will get 0.79. So it has asked you to calculate a relative error. So for relative error is your x star. So in this case we are solving for y. So let's better use y star minus y divided by y star. Right. So y star is, you have to calculate. So y star is solved at putting the value directly into the equation and getting the value. So y star would be 1.37 cube, sorry, minus 1.7 into 1.37 square plus 8 into 1.37 plus 0.35.
Okay.
So y star would come out to be
0.79 something.
Y star.
Substitute same equation, sir.
No. Here we had rounded off. Here you will directly put the value in your calculator. So in that case,
all digits.
so you will get 0.743. So your relative error would come out to be 0.743 minus 0.79 divided by 0.743, and you will take mod of it. So how much percent it would come? It comes out to be 6.32% if you are multiplied with that. So this was your y value when you are using a direct expression. Okay. Now let's go for a second one. So in B, what he is saying, you expand rather than using that, you expand it like I tell you and solve it. So he is asking you first is what x minus 7. So you will require x minus 7 here. So x minus 7 would be minus 5.63. Then x minus 7 into x would be minus 7.71. Then what x minus 7 x plus 8? X minus 7 x plus 8. What this would give you? This would give you 0.290. And finally this x minus 7 x plus 8 into x. This would give you 0.397. From this, if you put in the value of y is equal to this second equation in the B, what you will get is, so basically you have this value, right? 0.397 here. 0.397 plus 0.35. This would come out to be 0.747. So can you see the difference here?
0.79, 0.747.
Exactly. So this is the intricacies of numerical methods. So it's just not straightforward like analytical ones. So when you, so just for the completion's sake, let's get down to the relative error. So we know the y star would be similar, 7.743 minus 0.747 divided by 0.743. Now error is drastically reduced, 53%.
But comparing with all digits, sir, again, what is the error? Okay, same reducing.
So can you
Topic
just
is increasing.
the error is decreased in the second case, and for the first case it was higher. The error was higher. So can you just give me, and this would have holded if I would have rather than rounding off, rather than chopping off. You can try with the rounding something. It will hold. Say. Why would it do? Can you just comment? So you can see here there are the x, you directly taking their orders, and the value is in a fraction. So when the value is in a fraction, when you take its or what we say, when you take its higher orders, you are going to get a very long fractional numbers, and you are going, when you're chopping off, you are just reducing down at one step, and you are multiplying it very high number here directly. But in this case, the error is getting what we say equalized because of this expression. For each case, you are not directly rounding it off. Hello, you got me there, right?
Yes, sir.
You understood, right?
Signal problem I had, sir. 10 seconds back. Okay.
Yeah, so you got now, like, why it is different. So here it is getting what we say equalized while doing the expression extending because of these orders directly. These orders directly we are using the fractional number. The error is higher in the first case.
Okay.
Okay. So this is the second question. Let's move ahead for the third one. So this is the basic question now, like this is we doing it from I remember from 8th, 9th standard I am using these binary numbers. Maybe in your case, maybe in the 10, 11 standard somewhere. So we this is very straightforward, right? Can you do this? Like, let's say here it is not mentioned, it is signed or something. So this is a unsigned. When it is not mentioned, just considered a unsigned. So A is equal to 110.0101. So we'll start here. This is a 2 raised to 0th bit. This is 2 raised to 1th bit. This is 2 raised to 2 bit. This is 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4. We'll just multiply it. 1 into 2 raised to 2 plus 1 into 2 raised to 1. We will not consider zeros. Directly 1 into 2 raised to minus 2 plus 1 into 2 raised to minus 4. Right?
Yes.
So it is just 4 plus, this is 2, this is 1 divided by 4, right? So 0.25 plus, see here I 2 raised to minus 2. So 2 minus 5, and this is 1 divided by 16. So this would come out to be 6.3125. Right?
Okay.
This is pretty straightforward. There is nothing to be, right? So maybe you can try your second one. 0, 1, 0, 1, 1. So this is 1 into 2 raised to minus 2 plus 1 into 2 raised to minus 4 plus 1 into 2 raised to
minus 5.
minus 5. So this is 0.25 plus 1.16 plus 32. 0.34375. This is your decimal equivalent.
Okay.
This is done. So now we come out to the equations that were there, right? So there were three methods. So we'll solve this one. Have you watched this lecture?
No, sir. No.
Okay, so what we have given here is directly what we'll do is here they have given you one formula. Now the formula is directly given. So in the lecture, professor tells you about a Babylonian,
Yes.
yeah, that is a
Yes,
Henon
sir.
algorithm. You must have seen that. You seen, right?
Yes, sir.
So Henon algorithm is used for finding root 2. Similarly, now you have given for a root 7, cube root of 7. They ask you cube root of 7, and for this one there was an average of something x plus 2 by x something, right? Similar kind of a formula was there, right? Right? So that was there for Henon algorithm. Now what they are saying is x of I plus 1 would be 1 divided by 3 2x of I plus 7 xi square.
Okay.
Yeah. So similarly, now iteratively it is said and till it converges. So what do you mean by converges?
Near to the accurate value.
Near to the accurate value. So basically we are trying to get the reduce the error, and the zero would be great.
Yes.
Right? And iteratively means you have to do it again and again. So we'll just solve it. So for iteration it's always better to have a table. So for iteration, then the x value we are at, we'll just solve for this bracket xi plus 7xi and the error. We'll just calculate a simple absolute error. So that would be x. We don't know x star here. So in that case, what we will do? We will consider the previous value. Xi minus x I minus 1. So iteration 1. So it has the initial guess, it is given as 1. So
Okay.
initial guess we are considering 1. So if you put the value of 1 in this equation, 2 plus 7 divided by 1, 2 plus 7 is 9. Right? Here the error would be nothing. For the first iteration, we are at xi, but we don't have I minus 1 for a first iteration. So there will be nothing. Now, what is the value for second iteration? We have to take, we have got this bracket, let's divide it by 3. 9 divided by 3 is 3 only. Right? So that is your new value. So since you got the new value, you can calculate error. 3 minus 1 is equal to 2. Right? Now we'll calculate the bracket. So 3 into 2, 6 plus 7 divided by 4. Sorry.
3, yeah, so 3
6 plus 7 divided by 9.
Mm.
7 divided by 9. So that would come out to be 6.778. 7778. Right?
Okay.
So again we will divide it by 3 to get this value here. What value for the next iteration? So divided by 3 you will get 2.2592. Right? Since you got the next value, you can always calculate the error. The error would come out to be 0.7407. Right?
Okay.
Again, you can put the value xi of this third value in the bracket. This we can calculate this one, right? So that would come out to be 7.6168. Now 7.6168 divided by 3 will give you the xi for the next iteration, that is 2.5389. Now you take the error, divide minus 2.53 minus 3, mod of it, it will give you 0.2797.
Okay.
Yes.
Yes.
So you're following along, right? How we are calculating error, how, where, what happened. So now just again calculate the bracket. The bracket would be 6.1637. So we just plugged this value in this expression and got this value.
Okay.
Again divide by 3, you will get the next one. So that would be 2.538. That would be 2.0546. 0546.
Okay.
Okay. So again error would be 0.4843.
Okay. Again, increasing error.
Yeah, but let's see what happens. So here again the bracket would come as 5.7674.
Okay.
Now divide by 3, you will get 1.9225. Right?
Okay.
The error would come
Increasing.
0.1231. Is decreased. Right?
Okay, decreased. Okay.
Yeah, so it sometimes happens, so that's the beauty. So then again we'll calculate the bracket 5.78 5.7389. Again divide by 3, you will get what? Next iteration value 9129. Are you getting this?
Reducing in error.
Yeah, the error would reduce. Now it would come in the 10 raised to minus 3. So it would 0.009521. You could have, let's say, if you were iterating for a longer time, and then you could have said, okay, this amount of error is sufficient for my process. So I'll just stop it here. But let's see what happens on the next iteration. Okay. So here what we will get next one 5.7387. If you take divide by 3 here, again you will get 1.9129, and the error would come out to be 0.
Yes.
Right?
Okay.
So we could have stopped it here and we could have gone for the next iteration also, but our final value would have been so our final value would have been same. So it's always advisable if the error comes. So you see the process. If the process this error is manageable for that variable, then no need to go for a 0 also. You can this error is I can do away with this error. So that is a call that we take. So, both the cases the value would be similar only, right? Whatever the value that you are going to get for the variable would be similar. So let's just get cube root of 7. What is the actual value? So that we will call it as a x star. Cube root of 7 would be
1.9129.
Yeah. So it's more or less similar. Exact similar value.
Great.
So this is how it is. We'll move ahead with the next question. So do you need any break? Let's go ahead.
No, sir. You can complete it and then we'll take early closing. It's okay, sir.
Okay, fine. So let's f of x is equal to this. So the last one was iterative method, right? In iterative method, would have observed this expression is not infinitely increasing. You can have, but you can see it outside. Like after this class, you can check if you can. For let's take the next question and then you'll understand.
Exponential.
So we have exponential function here. Compute. So what they are doing is asking you to use a Maclaurin series. Compute and report the value for f is equal to point 1 for a Maclaurin series expansion until third order term. Maclaurin series. So what is a Maclaurin series? It is a special case of a Taylor series, right? So what is a Maclaurin series is f of x is f of 0 plus x into f dash of 0 plus x square divided by 2 factorial f double dash of 0 plus so on. It has already asked you for a third term, so better we'll just write the third term also. X cube divided by 3 factorial plus. So for a Maclaurin series, what you require? You require the value of the function at 0 and value of the function at each derivative. Is it easy to solve this function that easily, taking a derivative? You have to apply this one, right? Division rule, and then it will get very clumsy and all. So we'll just see first if we can. Let's first see if for a differentiation, is it a continuous function or not. So we'll first limit x tends to 0, f of x will see. E raised to x minus e raised to minus x divided by x. So if you put 0, it is getting into indeterminate form, right? 0 by 0 form. Right, we're just checking if the function is continuous. If the continuous, we can say that okay, we can at least try for a differentiation. Yeah, so that's what we're trying to do. So in this case, we can use a L'Hopital rule. So using L'Hopital rule, so in that case, what we'll do, limit x tends to 0. We'll take the derivative of the first one. This is x raised to x minus x raised to x and plus 1, and here it would come 1. So the value would be 1 plus 1 divided by 1, so 2. So since the limit exists, we can say that the function is continuous. So since this function is continuous, rather than doing this at a one go, what we can do is take a Maclaurin series for e raised to x, Maclaurin series e raised to a minus x, and divide by x. We can do that because the function is continuous. So Maclaurin series for e raised to x is straightforward. It's 1 plus, sorry, e raised to minus x will first be, so sorry, first is x now. E raised to x is 1 plus this is this one, x into f dash 1 0 plus x square divided by 2 factorial, this would be again 1 plus x cube divided by 3 factorial, this would be again 1, and so on. Right?
Okay.
E raised to minus x would be, because the second term is e raised to minus x, the first term would be again 0, sorry 1. The second term would be minus x divided x. Third term would be x square divided by 2 factorial. You're following along, right? You need to not explain, right? E raised to minus derivative of e raised to minus x is minus e raised to x, right? E raised to minus x. So that, and we are putting the value of 0. So for all negative terms, the value, the coefficient would be minus. For all positive terms, the coefficient would be plus.
Okay.
So the numerator is your e raised to x minus e raised to minus x. So 1 will cancel out. X minus x, it will become as 2x. Again x square and this one will cancel out. This will be plus 2x cube divided by 6.
Okay.
Right? Or you can say 2x plus x cube by 3. Right? But a function of x is e raised to minus x minus e raised to minus x divided by x.
Okay.
So it's x plus x cubed by 3. Right?
Final answer.
Hmm?
That is the final answer, sir.
Huh?
X plus x cube by 3, that is the final answer for that factorial function term.
Sorry, I didn't
Divided by-
understand you. This is the final answer for a function of x. But what they are asking you, calculate the f of 0.1. So you have to put the value of 0.1 there.
But divided by x, it cancels.
If for this term, what I have done is okay. I'll just. I thought that you might get.
One step you skipped and a little bit confusion.
Okay, no problem. I'll just again do it. No problem. So you got this one, right? So
Okay.
we are just dividing by x. So 2x divided by x plus 1 divided by x into x cube divided by 3. So x square xx. So
Okay.
2 plus x cube by 3.
Okay.
Yeah? Sure.
Yes, right.
So
Now
now it's straightforward. He's just asking you to calculate the value of f.1.
Now we can go easy. 2 plus 0.1 whole cube by 3.
So 2.0033.
Okay.
Right?
Right.
In the second question is asking calculate the true value of f.1. So you directly put that f.1 at the x and calculate what is f of x.
Okay, by calculator.
Calculator.
Okay.
And then asking you to calculate a relative error for the value
Okay.
obtained in the previous step. So will f of 0.1 star. So this is s 0.1 minus e raised to minus 0.1 divided by 0.1. This would come out to be 2.0033.
Okay, by calculator.
Yeah, 335 something, right?
Okay. Then error.
So then relative error again. So
less than 10%.
f star minus f divided by f star. So this is your f, this is your f star. It would come out by 1.747 into 10 raised to minus 5, I guess.
Oh, okay.
Which can be
Almost zero. Nil.
1747.
Yes, sir.
And for a point now, in next question it is asking you to f is equal to 0.01. So until third order. So you already have a function value, you just have to put the value of 0.01. F of 0.01.
2 plus 0.01 whole cube by 3.
Yes, You can go ahead and in the meantime you can later on calculate the error also. Okay.
Right.
So here you've seen this is infinitely long series, okay, but the question itself told you to do it for a third order term, okay. If you wanted a better accuracy, you could have gone for a higher order term also and got a better accuracy, but you decided, okay, I'm comfortable with this one, and in that case my error is also very low, so it's okay, fine, no problem. Third order term is sufficient for.
Okay.
Right? So here it is not iterative method. This is a direct method. Okay? Where the expansion, your expansion is infinitely long and truncating. Here the expansion, here the equation, the expression was the equation was not infinitely long. It was a finite. Now we'll go for this one.
Okay. Taylor series polynomial.
The Taylor series polynomial of a degree n is f of for f of x exponential function is given by this formula. So this Taylor series at this one is given to you. You did not use the actual Taylor series. They are telling you to use this one. Use the Taylor polynomial for degree 9 and 3-digit chopping arithmetic to find exponent at e raised to minus 4 by each of the following method. First is asking you to directly use this method. E raised to minus 4 is equal to Taylor series approximation till n is equal to 9 in this. And the second one, it is telling you to, since e raised to minus 4 can be written down as this, and then it can be used by Taylor series approximation as this, solve using these two, and tell me what would be the accuracy, which one will give you the better accuracy. Now this one and this one, analytically same again. E raised to minus 4 can be written as a e raised to 1 by e raised to 4, right?
Right.
So basically what A and B are analytically same. Let's see, are they numerically same? That's what this thing. And the n is equal to 9. So we are, in the previous case, the n was till 3 only. Now we are going till 9. Let's see what happens in both cases. Okay. So for their Taylor series, what they are telling you is, let's say first we'll take the A1, e raised to minus 4. So till 9 term, na? So 4 divided by minus 1. So that is the fine. Then the second term would be plus minus 4 square divided by 2 factorial plus minus 4 cube divided by 3 factorial plus minus 4 raised to 4 divided by 4 factorial, so on till minus 4 raised to 9 divided by 9 factorial. Right?
Okay.
So we'll just compute. You can use calculator here. So it would be minus 4 plus 8 minus 10.667 plus 10.667 then
approximately
minus 4
rest of the
raised to-
terms also 0. Plus minus alternate.
No, you have to calculate. So I am just written here, you have to calculate each step. Minus 5 raised to 5 plus minus 4 6 raised to 6 factorial plus minus 4 raised to 7 divided by 7 factorial plus minus 4 raised to 8 divided by 8 factorial. Each term you have to calculate. In numerical methods, you just can't round it off directly. We are trying to see what the gist of what the for equations. What the problems I am chosen is, I am trying to give you the gist of everything. Like, just can't directly round it off whenever you like. You have to see the numerical, what it is doing. You can, because we have we are trained to solve it analytically. In numerically, it is a different approach that we have to consider always. That's the gist of it. So here 8.5333. Then for this is first term, second, third, fourth, fifth. For the sixth term, 5.6th order 5.6889. For seventh order, it would be 3.2508. For ninth order, it would be 1.6254. And for ninth order, it would be 0.7224. Can you tell me what is the final value?
minus 1.1922.
Yes. 1.192, sorry. 1922. Just see how, let's, rather than do, now we have used this till 9th order. In the last equation, last question, we just used it 3rd order, and we got the approximately correct value, right? Here let's see what will be the f of x star. So you will directly get the value of e raised to minus 4. So directly e raised to minus 4, if you put in the calculator, how it comes out to be 0.0183. Is it correct? What's where? Yeah, we took the Taylor series correct one. We also did took the each and every value separately. Till we are getting so much error, right? So just if you calculate, so let's go for a second one, and then at the end we'll calculate the relative error. So second one, what we are doing is we are doing the reciprocal. So we are e raised to minus 4 by definition can be write as the 1 divided by e raised to 4. So
64% error.
60, not 64%. It would be 64 point something. It's just a fraction. You have to multiply it by 100.
Okay.
So it would be such 6,000 something error.
Yes. Right? Multiply by 100, it goes 6,440.
Yeah. So it's like you are doing a blunder. So there is an actual term. I'm not making it up. There is actual term blunder error. So this is a blunder error. Analytically it's correct, but numerically it's not correct. You are doing blunder.
Okay.
So here what we are doing is in second one they have told you to do the reciprocal, e raised to 4. This is correct. So by that then they have asked you to the Taylor series for e raised to 4 I divided by 1 I factorial. Sorry. 4 raised to I into I factorial. So nothing, it would be nothing but 1 divided by this term, but since e raised to 4, right? So there would be no negative sign, right? Are you understanding what would be the denominator?
E raised to 4.
So e raised to 4. So if you expanded it, it would be 4 plus 4 square divided by 2 factorial plus 4 cube divided by 3 factorial plus 4 raised to 4 factorial. So basically what we are doing is these terms would be similar here down there, but just this negative value, this negative sign would not be there. Are you understanding? Those all would be positive ones. So it would be 1 divided by 4 plus 8 plus 10.667 plus 10.667 plus 8.5334 plus 5.6889 plus 3.2508 plus 1.6254 plus 0.7224. Can you just tell me what would be your final value?
One divided by 53.1549. Denominator is 53.1549.
Okay, denominator. So can you tell me the final value?
Sir, that is plus 4 or minus 4, sir, starting term?
Starting term would be, sorry, this would be plus 4. Sorry, my. So because 4 4 raised to 4 plus
0.0188.
yeah 0.0188. Is it close to the actual value?
0.0183.
Yeah.
Yes.
So the relative error would be
Hmm.
0.183 minus 0.0183, right? 0.0183 0.01 divided by 0.0183.
Error is 2.8. Okay.
Yeah, 2.73 something. Yeah.
Mm-hmm.
So you can say that analytically they were both similar, right? But the final values that you are obtaining, and you are using the same expression. So are you understanding the intricacy and the beauty of it? You are using a similar expression of the expansion. You are using it to the similar order. You are using again the what we say e raised to the values are similar, but it is not matching up.
Yes.
So the why it would be like in this case the error was blunderous 65 something 65,000 plus error. And this is some 2.73 error. This is fine. This is approximately fine. It's very much good. So in the relative terms. So why do you think the case is?
It is there in the series problems only, sir, the way of writing of the series.
The series we are used the similar series in the second one also, right?
But it is reciprocal, there is without reciprocal.
Yeah, that is true. Reciprocal is fine, but what is causing the error to remove? And the first one, the error is so huge. So if you see the expansion, of the e raised to minus 4, e raised to minus 4 expansion, if you see, there are negative terms, right? There are these negative terms, right? And there could be a case when this negative term might cancel the positive term. So here it is happening here. Are you understanding? Here this is cancelling this out. So they are cancelling each other out. So you are reducing down the inner what we say intricacy of the problem itself. So you will always get an error when there will be a negative sign associated. So it's always better to have a positive signs, so that you are. So that is why the reciprocal is working, because the e raised to 4 is there. So even if you get the e raised to 8 and you tried e raised to minus 8 and tried expansion of it, this would fail. But e raised to 8 normal expansion would be correct. Then the you need not take reciprocal, because in e raised to 8 there would always be a positive signs that are adding up. Here in e raised to minus 8 there would be negative, positive, negative, positive, and then you are removing them each other out. So it's better to just take the additions and multiplications in the to have a better error in these terms.
Okay.
So this is the problem. Now we move on to the last one.
Okay.
Yeah. So this is the last one, Taylor series expansion. So this is your Taylor series expansion, and here we talked about error analysis. Now we will talk this Taylor series. So there is something called a sequential method. So we'll talk about this. So what they are asking you, use Taylor series approximation truncated to the second order. Only take 2 orders and find me what is the cos of pi by 2 plus 0.3 starting from a is equal to pi by 2. So you might not have you gone through this lecture?
No.
Okay, we can go
I'll see.
it later. I'll just go through the solution of this. So what it is asking you, use a Taylor series approximation. So Taylor series approximation is f of x would be f of a, f of a plus x into f dash a plus x square divided by 2 factorial f double dash a plus x cube divided by 3 factorial f triple dash a plus so on, and did second order only, so we need not take these things,
Okay.
right? Now there is a concept of a step size here. So it is starting from a, and then there is a asking to step size. So we can always my apologies, have this series is wrong. X minus a f dash a plus x minus a bracket square 2 factorial f double dash a. This is your Taylor series. There will be higher order terms I am not considering. So what in sequential method what we do is, let's say you want to find out f of 0.03, okay, of something, of some equation, of some function. Okay, what you will do is, you will rather than putting f of 0.3, what you will do, first you will find out 0.1. So this 0.3 can be written as a 0.1 plus 0.1 plus 0.1, right? So first you will calculate 0.1, then that you will use to calculate f of 0.2, then that you will use to calculate f of 0.3. That you do. So rather than you have 0 and rather than you have a 0.3, rather than going directly to the 0.3, what you will do, you will step it out. 0.1, 0.2, 0.3. You will do something like this. This is sequence. So in the first case, it is telling you to directly solve it. So I'll just, for a completion's sake, step size, how you can say this x minus a, right? This formula, Taylor series formula, can also be written as in the terms of a step size. X minus a is equal to h. Then your x would come out to be a plus h. Then there will be f of a plus h is equal to f of a plus h f dash a plus h square divided by 2 factorial f double dash of a. Right?
Okay.
What we'll do is, the time will not be sufficient. You can do it the second order. What we'll do is, rather than doing it to the second order, we'll just take a second term. So we will remove this part also. Okay.
Can you use the Excel sheet, sir, for this type of
It's always better. I'm telling it is Excel sheet is the first one. Then you can try for a MATLAB also. So in this course, sir has some tutorials with the Excel sheet, and you can calculate those values. There is no problem with that. I'm solving it on the pen and paper just to get you the feel of it. And we are solving the equations, but I'm trying to give you some concepts out of each equations. Like there is some takeaway with it, right? So okay. So for the first one, in this thing, f of a would be, hello?
sir.
Yeah. So in our case, the f of x is, this is cos of x, right? So cos x is our f of x, right? So then your f of a would be just cos a. We require f of a, that's why I took f of a. Then f dash of a. And f dash of a would be cos a, derivative is minus sine a. Now since we know that sine square a plus cos square a is equal to 1, can we write f dash a is equal to under root 1 minus cos 1 minus cos square a?
Minus cos square a, f dash of a.
Right? This I'm rearranged, and this sine square a that is why take took under root. That is a minus sign. Here minus sign would be there.
Okay.
Yeah. So since cos square a is nothing but square of your f of a, so f dash a would be minus of 1 minus f of a square. Correct, right?
Okay.
So in the first one, what is saying you, here there should be a one line, then it would be complete with a step size of 0.3. Then it's straightforward. So the first one, because it is not given, it is but understood that you have to directly use h is equal to 0.3. Okay, so you f of what they are asking you, pi by 2 plus 0.3, that is f of pi by 2 plus 0.3. Right? So you have to use which formula? This formula. So h of f of a, this is your a, this is your h in this case, right? So cos of f of a is cos of pi by 2 plus h is your 0.3. F dash a, you have this for equation. So into negative 1 minus cos pi by 2 bracket square. Cos pi by 2 is 0, right?
Pi by 2 is 180 by 2 cos 90.
Cos pi by 2 is 0. 0
Yes,
plus
90.
0.3, then this is,
And there is
this
also
would be
1 minus 1.
minus 1. So your value will be minus 0.3. F of pi by 2 plus 0.3. Okay. Rather than this, in the second one, what they are doing, rather than using directly this value, directly going into the one step, what they are telling you is go into step size of 0.1 and compute the similar function. Similar function at the cos x function at pi by 2 plus 0.3. The starting again a is equal to pi by 2. So your b would be, first it is f of pi by 2 plus 0.1. What it is given, I'll just be elaborative. So h is equal to 0.1. F of pi by 2 plus 0.3 you want, right? F of pi by 2 plus 0.3 you want, and a is equal to pi by 2. So there would be three steps. First would be f of pi by 2 plus 0.1. This would be h. You will get some value, right? Then f of pi by 2 plus 0.2. This would be f of pi by 2 plus 0.1 plus 0.1. So this whole is your h, and this is this is whole is your A and this is your H for the second second step. And for last one, this is your pi by 2 plus 0.3. It would be f of pi by 2 plus 0.2 plus 0.1. So this is your H and this is your A for third one. So this is your first one, this is your second one, this is your third one. So you are going in the sequence. First the first part, then you are compartmenting it, taking the H, right? So the beauty of it is, for this value for this one you will know this A value from this solution, so you will directly put it here and H. For this one you will know this solution and directly put it here and get the solution. So we'll just do that. So f of pi by 2 plus 0.1. First one is what? F of pi by 2 plus 0.1, right? So that is what function did you get? F of A plus H of f dash A. So I'll just write it here for your f of A is equal to f of A plus H is equal to f of A plus H plus A. F of A plus H is equal to f of A plus H into f dash A. This is your function, right? So this is your function, right? This is your function, and you can your A value is here, your H value is here. You can put it in this one. F of A would be cos of, so f of x is your, f of A is equal to cos A, f dash of A is equal to minus under root 1 minus cos square A. This thing we got in the last one. So the similar thing, cos of pi by 2 plus H is what? 0.1 into f dash A minus, so this would become plus, this would become minus, right? So what we'll do is this will become minus
again pi by 2
1 minus cos pi by 2 square
0,
so
that
0
again,
is will be 0.1, right? So you got, this is what this is was f of pi by 2 plus 0.1. Now in second step what we'll do, f of pi by 2
plus 0.1 plus 0.1.
Yeah, exactly. So here this whole is your A and this is H. So cos of pi by 2, f of A would be cos of pi by 2 plus 0.1 minus 0.1 into, so I am directly multiplying this minus here, 0.1 into root of 1 minus cos of pi by 2 plus 0.1 square. So you directly have this value here. So this value is what? Minus 0.1 into under root 1 minus 0.1 square.
Okay.
So what value do you get?
Okay, cos of 0.1. Minus 0.199.
Yeah, minus 0.1994. that one you will get. Similarly, here is your pi by 2 plus point. So for a third one, you know the drill now. F of pi by 2 plus 0.3 is would be f of pi by 2 plus 0.2 plus 0.1. This is your A, this is your H. F of pi by 2 plus 0.2 minus 0.1 under root 1 minus f of pi by 2 plus 0.2 square. Right. So again this minus 1994 minus 0.1 into 1 minus 1994 square. You get?
Okay. Yes, 0.2973. In values is increasing. Okay.
Value is increased.
Negative
Value is
values.
decreased. It's going negative, right?
Yes, decreasing.
So yeah, this is what it is. This was about the equations and solutions. I took this final equation solution because you have a similar question in your assignment.
Okay.
So and someone had a doubt about this. They had written down. I don't know why I don't get to know what their name is. It's anonymous to me, but there was a doubt with the question. So I just thought that okay, I'll take the similar type of question.
Okay.
So this is about the session, the questions. So just let me know, are the questions okay? Are you understanding, following along?
Okay. Yes, sir. Yes, sir.
You understood the concept?
Those who are going for first time, lot of confusion came. And one more thing is remembering of this series is also again follow.
Remembering
that is,
of what?
With remembering of this series, Taylor series, Babylon series, formulas.
So not everything is required, but Taylor series as an engineer, everyone should know. Taylor series is nothing. It's very easy. Taylor series is what it tells you f of x. It says that the f of x can be approximated with the additions of higher order terms. So it's I is equal to 0 to n, where then x of I, so x of I divided by I factorial into f dash of f of n of a. So I don't even remember the formula. I just know the concept. So what it says is addition of different addition of each and every term. So it is what, if you expand it, is x first would be x 0 divided by 0 factorial into f0 of a. Right? So x0 divided by 0 factorial, so x0 is x0, 0 factorial is again 1, f of 0 is here this. So this would be f of a only, thus x. So this is how it goes. So sorry, this is not x0, this is x raised to I. So it is x raised to 0, right? So this would come out, x raised to 0 is 1, f0 is f of f at that point. right?
Mm.
So if 0 is nothing but first zeroth derivative means the actual function itself. So that is a f0. Then at a, then x raised to what we say. Then the second term would be x raised to 1 divided by 1 factorial if first derivative of a plus x square divided by 2 factorial
Mm.
and so on, triple derivative of a and so on. Similarly you will get, so it's nothing, we'll just give a easy look at just 2-3 times if you wrote it down now. Here is the second derivative.
Okay.
So this is a Taylor series approximation, and for Maclaurin, if you consider fa is equal to, rather than approximating at a particular value of a, if we approximate it at a origin, then you get the Maclaurin series. So this is your Taylor, this is Maclaurin. This is approximating at origin. This is approximating at some value.
Okay, sir, can you, could it possible to give me real applications? Exactly this series, how it will be helpful for suppose real application calculation means not this. I'm talking about real time application means if you conduct some experiment, something,
it's
how
very,
it will be helpful.
It's very easy. So what I will give you is
I have some on experimental data for this. How it will be helpful for this to relate to numerical methods.
Do you know liquid tank system?
What is that, sir? Pardon?
Liquid tank system.
Liquid tank system. Means height of measurement of the
So
water.
there is a flow rate is coming in, there is a flow rate coming out, and there is a height inside it.
Okay, sir.
Right? So
Liquid
there
tank.
is, if you apply the first principles, first principles, so I guess this would be going out of the syllabus right now. So what I'll tell you is, we will go.
We are learning actually. Why I'm asking this doubt means I seen Srinivas Ramanujan movie because he wrote so many theses and hypothesis theorems. But their professor, they told how you can write that one. They give an answer. The God is they're giving the ideas, and that is the reason I'm writing. But his failure is real application. Is not given whatever is given written his theorems and hypotheses. But real application is not exists. He cannot able to prove it within because of less of the span. That is the reason major failure is happened because of by movie only I know that.
Okay. Yeah, in movie they do some dramatization, that's okay, and there might be a case where it is something coming from past life and everything, that is a different thing. But here what I'll suggest you is, this is just the first introductory course, so
okay, so now signal is okay.
This is sorry for this all the time interruptions. So what I'll suggest is the first introductory course. Go through the first 2-3 courses. Sir will explain you, use some practical examples in this one. And what I'll tell you, if you want to, you see where the Taylor series in particular is useful. So Taylor series is all useful to approximate some function. So you go for this first liquid tank system. Just Google it, check its first principle model. Okay, Google this first principle model, and after googling it, see how they have solved. they must have used somewhere a Taylor series. So Taylor series is a fundamental thing to build upon it. So if your Taylor series, because it's a differentiation, you can write it as a differential equation, and then again you can extrapolate it by solving. Sorry, not extrapolate. You can evaluate it by solving order differential equation formulas or do some. So that we'll see in the next coming classes. So a practical example you will see along when the time comes. This was just an introductory error analysis and everything. So this is
real physical application will comes under next coming sessions.
Yeah, it will come. So first we will see what are the linear equations, where they come about, where they are used. Then we will see what are the non-linear equations. Then we will see how to solve when you have a data set, how to fit the data to the regression and interpolation. Then we will see if you have an ordinary differential equation, how to solve. If you then order differential equation, system of order differential equations would be there. So the one equation will depend on the second one and the third one. So system ordered equations are there. How to solve them. So all the week in the 12 weeks you will get the hang of it.
Because the rememberness it comes from the real application.
Yeah,
that is the reason I asked.
Yeah, that's true.
Thank you, sir.
Yes, sir. So if you have any doubts, there is a forum, Google forum sheet also. So you can put your doubts there. I will try to address them in the next sessions. Okay.
Thank you, sir.
Yeah.
Okay.
Okay. Thank you.
Okay. Bye.